Okay, so in the previous video, what we did is we came up with expressions for C of n for this algorithm, so for every single one of the different operations. So we know exactly how long each of the operations will take now as a function of n. So now let's write our complete expression for T of n, for the execution count, or for the runtime of the sequential search algorithm as a function of n. All right, so what is T? And I'm going to call this TSS of n. So this is the total time, the total running time of the sequential search algorithm. Well, it's equal to this, TSS of n. We already know that this is the sum of I starting at 0. In this case, going up to 6, of the time it takes operation I to execute times the operation count of operation I as a function of n. And we worked out all those CIs on the previous page. So I'm going to leave the little TIs as TIs for now, because I don't know what those are yet. We'll see. We'll kind of put off having to put numbers in there until the very end. But now I actually do have functions for all of these CIs. So let me give you the simplified version of this, if you will allow me to. All right, so this is the following. And so here I'm gonna ask this question in worst case. So I'm gonna say, what's the worst case running time? What's the for the worst case execution count for each of these? So this equals the following expression. So this is T0 plus n plus 1 T1 plus nt2 plus nt3 plus t4 plus t6. Okay, and I can combine terms. I can combine this so that I have an n and a not n. So let me combine all my n's, and I have n times t1 plus t2 plus t3. And all my not n's, and I have t0 plus t1 plus t4 plus t6. Oops. Okay, and there it is, right? So if I know all of these execution times, then I have my full expression for TSS. So here's almost what we were looking for of n, is this big honkin' thing right here. Let me simplify this in just one simple way. So let me simplify it like this. Let me say I'm going to collect these terms into one thing, and I'll collect these terms into one thing. So let me call the T1, T2, T3. Let me call that, what am I doing this in the notes? I don't have a term for it in the notes, so I'm just going to call this, A. And I'm going to call this B. And I can write this in a slightly simpler format, and I can just say this is n times A plus B. Okay. So there's our expression. So now what do we do with this expression? So what next? What's useful about this expression? Well, I could, if I wanted to, if I was really interested in knowing the very detailed answer, I could go into my computer system, figure out all of these T1 through T6, and that would involve choosing a particular programming language, choosing a particular interpreter for that language. That would involve making sure that I've set up my system to be exactly the way I want it to be, and so nothing else is running that can cause interrupts that'll change the execution time of each of these things. And so I could go find all these little t's. I could go actually characterize the A and B for my system. But the question is, should I? Okay, so the question, I guess, in a more fundamental way, the question is, do I need to know A and B? Right, and and what would it mean to not need to know A and B? So do I need A and B. And what would it even mean not to need to know A and B? Well, here's a particular question I could ask. All right, and this question might sound a little bit strange at first because it feels quite different from the original question I asked. Recall the original question I asked was time, right? So let me call this question 1 is what's the time it takes for this thing to run? And the time comes in seconds, right? That's measured on a clock. So time, I mean, I'll make the argument that the time question is a question of architecture. So it's a question, it's a very specific question that's going to be specific to my system. So this is system specific. And it's an important question if I'm trying to make my system run really, really fast. Like if I'm doing embedded signal processing, I actually do care very much about Q1 because I'm building something that's maybe a little bit purpose-built, and so I know what the system's going to be. But in this class, we actually end up asking a different kind of question. And the question goes something like this. And I'm going to use the word sensitivity, and then I'll explain a little bit what I mean by that. And then I'll spend the rest of the semester explaining more what I mean by that. And so the question that we're going to ask is something like this. How sensitive is the running time to the input size? Is time, and I'll just call that time. And you'll understand that when I say time, I mean running time. How sensitive is the running time to the input size? And so one possible way I could ask this question is something like this. How much does the running time change if I double the input? How does T of n change if n doubles? And that's a question we're going to spend the next week or so really sinking our teeth into and trying to understand how this question can be answered in a rigorous way for arbitrary algorithms.